electrostatics?
So electrostatics would be better.
I should start from the electrostatics, okay?
Yes, sir.
Okay, fine. Okay. So electrostatics is the first first unit, you can say, of your 12th class, and in the 11th class you have studied about the mass. Means there you will see masses are moving with some velocities, acceleration and all that of masses.
Yes.
And here in the electrostatics, in the 12th class, or you can say, you will see masses, and along with that there is an additional property of matter we will study, and the effect of that study is charge. We will study about the charge, and we will see what will happen due to the charge. If the charge is at rest, then what will happen? If the charge is in motion, then what will happen? Charge in rest we will study in electrostatics. Charge in motion we will study in current electricity and electromagnetism. We will see that. So electrostatics, in the electrostatics we will study the charges at rest. Rest means charge is not changing its position with respect to time. So firstly, I will define the charge. So charge is the intrinsic property of matter. Charge is the property of matter, and matter is this is matter. I am also matter. All things are matter here. Matter is something which have space and have mass. Is known as matter, and charge is one of the property of matter. So you can say charge is property of matter due to which if I am talking about this chapter, then I will write electric force electric field. We will discuss all these things, electric force, electric field, in this chapter.
Okay.
And you can say electric energy. We will see this in the capacitor energy produced. And in this, as this is a demo class, so I am not going in the detail of the charge, but that will become very much theoretical. So I am just telling you charges are of two types: positive charge and another type of charge is negative. And suppose if I am giving you two charges, suppose here is a charge Q1 which is positive, and here is a charge Q2 which is also positive. So this is very small charge, or you can say. So these are two positive charges, and these charges are placed at certain distance apart. So both positive charges, they will repel or attract each other? They will repel each other.
Repel.
They will repel each other with some force. This charge will also repel this charge with some force. You can say repel. So if I have taken a charge Q1 here, now instead of Q2, I have taken a charge minus Q2. So they will attract. Attract means attracting is like this. You are
Yes, sir.
and repelling is like you are going away.
In the opposite
Attracting means
direction.
coming. Yeah. With some force have, and there is a certain distance in between these charges. The distance can be 1 mm, 2 mm, 3 mm accordingly. And charge is a scalar quantity. There are two types of quantities. Number one is a scalar quantity. Scalar quantities are those quantities. First, I am giving the example. Scalar quantities are like speed, distance, work, energy, power, charge. Charge is a scalar quantity, and scalar quantities have only magnitude. Magnitude means amount of
Yes.
charge. What is the meaning of magnitude? Magnitude means like if you are applying a force of 5 Newton, so that 5 is a magnitude. Okay, that 5 is a magnitude of the force, and if you are applying that force in certain direction, suppose this is I am applying, I am talking about the force. Okay, I am applying a force in this direction, and there will be a magnitude also, means how much force I am applying,
Yes,
like
sir.
this, like this. So the amount of force I am applying is a magnitude, and the direction, east, west, north, south, and all that are the
Yes.
direction. The force can be in the direction also. So charge, for the charge, you can say charge is a scalar quantity. Scalar quantities have only magnitude. We will not define the direction for those quantities. Suppose there is a charge of 5 Coulomb. So there is a charge of 5 Coulomb. No need of direction. What is okay? So that is why charge is a scalar.
Okay, sir.
Fine. And unit of SI unit of charge, SI unit. We will use this SI unit in 12th class syllabus CBSE. You are from CBSE, na?
Yes, sir.
Yeah. So in CBSE, mostly we will use SI units. Uh, if there is something which is not in SI unit, we will convert those things in SI unit. So SI
Okay.
unit of charge is Coulomb. SI unit of charge is Coulomb. Now we will talk about the Coulomb scientist. So Coulomb, now what will happen? We know that if there are the charges, and these charges are placed with a certain distance, Suppose this is one charge and this is another charge, and this is the distance between these two charges. And one thing more I want to tell you, there is a medium around the charges also here.
Yes, sir.
These charges here are placed in air. Here in my room there is a air, so these charges are placed in air. Now these charges can also be placed in oil. These charges can also be placed in some other medium like gases.
Yes, sir.
These charges can also be placed in water also.
Yes.
So here the charges are there, and these charges are separated by certain distance, and we know that positive repels. So these charges are at certain distance apart, and you can say there will be a medium here. Any medium will be there in between the charges. I have now not defined the medium. So Coulomb said that to calculate this force, the force of attraction or repulsion, there are certain things Coulomb told about this. Okay, and then we will discuss, and that is the next topic, Coulomb's law. So why we are studying the Coulomb's law? Because we want to find the force of attraction or repulsion in between the charges. So Coulomb told that how we will calculate those forces. So next heading is Coulomb's law. This is the name of the scientist.
Yes.
The scientist has given the law, so that is why this is Coulomb's law. So Coulomb's law, very simple. For this, I am just taking two charges. This is charge Q1. This is charge Q2. And this charge Q1 and Q2 are point charges. Point charges means very small charges.
Okay, sir.
Means point charges means charge in very small region of space, like this point. You can say this charge is this much small. And these two charges are separated by certain distance. These two charges are separated by certain distance. And I am saying this distance is r. Small r is the distance between the two charges and this point charges. And one thing more. These charges are placed in some medium. The medium can be air, the medium can be water, the medium can be some gas, the medium can be dielectric, that we will study later. So these two charges, 2 point charges, are placed in certain medium. And I am supposing these two charges as if you are supposing these two charges as positive charges, so you know that these two charges will repel with some force.
Yes, sir.
Yeah, with repel with some force. Repel with some force. So Coulomb said that, number one, he said that this force of interaction, this is the force of interaction. Force of interaction F. I am representing this force with F, and this F is directly proportional to the product of magnitude of two charges. Product of magnitude of two charges means if you will increase the amount of charge, if you will increase the amount of charges, then this force will also increase.
Yes, sir.
Second point is this force is inversely proportional to the distance of square of distance between them, means when you will increase the distance between the charges, the force will reduce. And third point is this force of interaction depends upon medium in which these charges are placed. In which charges are placed. For this, we will study the electric constant. I will discuss later. Means I am just saying that suppose you have taken the. I am just telling you the meaning of this statement. If now suppose this charge in some medium right now. Suppose you have changed the medium, means in between these two charges now there is some another medium like water. So the force of interaction will change.
Yes, sir.
And fourth point is F, this force of interaction acts always along the line joining the two charges. Yes, this is very important point. F acts always along the line joining the two charges, TWO two charges. So what this statement means, suppose if you have two charges like here, Q1 and Q2, the force will always be either in this direction or in this direction. The force cannot be like this. Always the force is along the line joining between the two charges. Line joining between the two charges. Here it can be like this or it can be like this according to the repulsion or attraction. Not like this. Coulombian force will not be
Okay, sir.
like this. So this is the meaning of this point. So now, when you will combine all these points, you will get a result. Force is directly proportional to Q1, Q2 divided by square of distance. And when you will remove this proportionality sign, and in the 11th class, if you have studied, you have removed many proportionality sign, and when you will remove the proportionality sign, like potential difference is directly proportional to the color current, and when you will remove this proportionality sign, you will get a constant here in the
Yes, sir.
Ohm's law. If we are talking about the Ohm's law, so similar in the similar way here also, when you will remove the proportionality sign, you will get the constant, some constant f. If you will remove the proportionality sign, you will write like this: constant k is the constant here, q1 q2 divided by r square, and the value of this k, and these charges are placed in some medium. We don't know the medium, we are just defining the medium, and the medium can be the medium, and that medium can be air, medium can be water, medium can be oil, medium, etc, etc. There can be. Okay, so here the value of k is 1 upon 4 pi epsilon suffix m. Okay, 4 pi epsilon suffix m, and epsilon m is the permittivity permittivity of medium. Epsilon m is the permittivity of medium, and
So what's
this,
permittivity?
we will discuss this, the permeability.
Okay, sir.
Permeability is the, just you can say that, uh, suppose here are two charges placed. Okay, here
Okay.
are two charges placed, and if you will define the permeability, then you will say, when you will change the medium, when we will change the medium, and the electric field due to these charges will change due to the permeability. Okay,
Okay, sir.
yeah. So we will discuss the permeability in the later. Actually, at this point of time, uh, you will not understand, you will not get what is permeability is. Okay, so epsilon of epsilon suffix m is the permeability of the medium. Okay, so I am just writing, if you want to calculate force in some medium, f suffix m, I am just writing. So you will write k q1 q2 divided by r square, and you will remember this formula, and also you will remember k is equal to 1 upon 4 pi epsilon suffix m. This is the permittivity of the medium. Actually, if we will talk about the permeability, what happens? This permeability is reduce the force of interaction. This permeability produces its own field. Actually, this is the property of medium. This is the property of medium. If you are placing a charge in water, and now if you are changing the medium, so permeability basically is the property of medium that opposes the force of interaction, means decreases the forces of interaction. Okay.
Okay, sir.
Yeah. This permeability due to the property of space like water or air, so that medium naturally creates its own field and try to reduce the force of interaction in between. Okay, fine. So here the charges are placed in medium. Now suppose if I am placing these two charges in air, when charges are placed in air, now you are placing these charges specifically in air, same system you are placing in the air, and the distance is again same. Distance is r between the two charges is small r, and again these two charges are the point charges, and this time the medium in between these two charges is air. Now the force of interaction, if these two are positive charges, will be like this along the line of action. You can say
Yes.
k q1 q2 divided by r, but this time the value of constant k will change, epsilon 0. This time you have epsilon 0, means this is the permittivity. Permittivity, you can say permitting the force. Okay,
Okay, sir.
permittivity of air. Earlier I have written epsilon m, permittivity of medium. Epsilon 0 or epsilon naught is the permittivity of air, and the permittivity of air is written as 8.85 into 10 to the power minus 12. And when you will put this value here, and when you will calculate this, you will get the answer 9 into 10 to the power 9, the value of k. Okay, fine.
Yes, sir.
So for air, I am writing, if two charges are placed in air, then you will use this formula. You can write in terms of k also, depending upon you, or you can write 1 upon 4 pi epsilon 0 q1 q2 divided by r square. Depending upon you, simply you can say f is f. If two charges are placed in air, then the formula will be k q1 q2 by r square, where k is equal to 1 upon 4 pi epsilon naught. And generally 99% in 99% cases that you will see charges are placed in air. If nothing is given, then you will consider the charges are placed in air by default.
Okay, sir.
Yeah. So this formula is more important than previous one. So this is all about the Coulomb's law, how we will calculate the force between the 2 point charges. Now there are some limitations of the Coulomb's law. There are some limitations. There are some limitations of Coulomb's law charges cannot be only point charges. There can be a charge which is very much bigger. There
Yes, sir.
can be a charge which can be very much bigger charge. Like you can say a charge of size of Earth. That we cannot say that is a point charge. With respect to distance, we will say, but there are charges other than the point charges also. Okay, I am not going in that detail. So this law is only valid for point charge. This law is only valid for point charges. Valid for point charges, or you can say 2 point charges. And you will see here that these two charges are in rest position, are at rest. Two charges
Yes,
are
sir.
not moving. These two charges are not moving. So this law is valid only when two charges are at rest. Two-point charges are at rest.
So this is only for Coulomb's law?
Yeah,
Okay.
I'm just writing again limitations of Coulomb. Limitations of. Now it's fine.
Yes, sir.
These are the limitations of Coulomb's law. We cannot apply Coulomb's law if charges are in motion. Both of the charges are in motion.
Okay, sir.
Now I want to this law is valid when two-point charges one of the point charge is at rest and another charge is in motion, but the distance between them is fixed. Distance between them is fixed. So now see how this will happen. This is a circle, and suppose at the center of the circle there is a charge q1, and this charge is at rest. This charge is at rest. Now suppose if a charge is here This is charge Q2 here, and this charge is moving like this. This charge is moving like this. So see here, this charge is at rest and this charge is in motion. But when you will measure the distance between the two charges at any point of this circle, you will get same. The distance is fixed here, and one of the charge is at rest and another charge is in motion. So here the Coulomb's law will be valid.
Okay, sir.
And there is a similar case of this. Electrons revolves around the nucleus in the circular orbit. So in the center there is nucleus and the electron revolves around. This is the electron. This electron is in motion in this direction, and this is the radius. You know that nucleus is in the center.
Yes, sir.
In an atom, nucleus center, electron is okay like this.
Yes.
So here I can apply the Coulomb's law. Here I can apply the Coulomb's law. Okay, if you can calculate the force of interaction, means here we will the force of attraction because electron is the negative charge and nucleus is positively charged because of proton. So here
Yes.
you can apply E, and there are, suppose n is the charge on this and k is the constant divided by distance square. And one thing more, just I am telling you additionally, do you have any idea about the circular motion? How the circular motion, how a body performs the circular motion, what are the requirements of the circular motion? Do you have any idea? If no, then no problem. I'm just
So it's
asking.
better if you teach it.
Okay, fine. Actually, I'm just want to tell you this force of interaction is responsible for the circular motion of electron. This force here, this is the electric force,
Yes, sir.
and this electric force provide the centripetal force. Centripetal force, and centripetal force is required for the circular motion. If there is no centripetal force, no circular motion will happen. Okay,
Okay.
this is the thing I want to tell you.
Okay.
I am not going in detail. This is a topic of 11th class.
Yes,
That
sir.
is enough, I think,
Yeah.
for 12th. Okay. Two charges point charges are placed in air at separation at a separation of d. If the separation between the charges becomes 3 times. And magnitude of both charges becomes 3 times then find the separation between charges if the force of interaction of interaction will remain same. This is the question. We have two charges initially. I am just supposing two charges as Q1 and Q2. Initially, we have two charges in air. They are placed at a distance d. They are placed at a distance d in air.
Yes, sir.
So we know that when the charges are in air, I am representing the force in air as F0.
Yes, sir.
So the value of F0 will be K Q1 Q2 by distance square. K will not change because this is air. Q1 Q2 divided by d square. This is equation 1. Now they are saying that two charges are like this, and read the question. Separation becomes 3 times, means this is d, separation this time will become 3d,
Yes, sir.
and they are saying the magnitude of charge becomes 3 times, means earlier it was q1, now it will become 3
3Q.
q1.
Yes, sir.
And again these charges are in air, so you will apply the formula F, because you have changed the distance, you have changed the magnitude of charges, so maybe the force will change. So I am just representing this force as F, simply F.
Okay.
So K is 1 upon 4 pi epsilon 0. This will not change.
Yes, sir.
1 upon 4 pi. This will not change. Epsilon 0 will not change because the air is there.
Yes, sir.
No, but this time for Q1 you will take 3Q1.
3Q1.
Product of two charges.
Okay, sir.
And again here you will take 3Q2
Yes, sir.
divided by distance square. This time
3D square.
3D square. And what was the question? Actually, we have to find this separation. We don't know what is the separation. We have to find this separation. Okay.
Okay, sir.
We have to find this separation, and I am supposing this separation as d1.
Okay.
Question. So here I will not write 3D. In the question, it is given that forces are equal, and you have to find the separation. So right here, this time the distance is d1,
Yes,
d1
sir.
square.
Yes.
This is the equation 2, and they are saying that both forces are equal.
Yes, sir.
find the separation between two charges if the force of interaction will remain same. Means for this force and this force is equal. Equation 1 is equal to equation 2, you can say.
Yes,
So
sir.
you can say F naught is equal to F. So what is F naught? Divided by D square.
These two.
Divided by, and F is, this will become K into 3 3 is a 9. Can I multiply this? 3 3 is a
Yes,
9,
sir.
Q1 Q2.
Yes, sir.
Q1 Q2, and we have to find this distance D1. We have to find this D1.
Okay.
So now this K gone, this Q1 gone with Q1,
Yes, sir.
this Q2 gone with Q2. Now here we have,
9.
here we have 1 by D square,
Yes, sir.
and here we have 9 by
And by these two.
D1 square. And when you will
Mhm.
take the square root on both the sides, when you will take the square root on both the sides, this is just a simple thing. So you will get 1 divided by D, and here you will get under root of 9 is 3.
Yes, sir.
You will get 3 divided by D1.
Q divided by D.
D.
D1. Yes.
So we have to find the value of, now we will cross multiply this. This will become D1 is equal to 3 times of D. This is our answer. Means we have to place the charges at a 3 times of distance of initial distance, so that the force will be same in between the two charges.
Okay.
So this is, so these types of questions you can get your examination also. The variation of this question you will see in the books also. They can ask you the force by changing the distance. They can ask you the distance by changing the force, or by when the force is remaining same. So Ziyad, do you have any doubt from here to here? We will discuss.
No, sir. No doubt.
Okay. So this is just simple things. These are just simple things. Now you have to remember what, not always, generally the students know the Coulomb's law for F is equal to 1 upon 4 by epsilon 0 Q1 Q2 by R square. Not that, that is not the Coulomb's law. Coulomb's law is this. There are 4 points. You have to consider, you have to consider the distance there also. No, not the distance, medium also. If you will change the medium, the force will change. We will
Yes, sir.
see, we will see when we will study the dielectric constant. We will see this when we will study the dielectric constant.
Okay, sir.
So yeah, so this is all about the today's class. And again, I am asking, if you have any doubt in this, you can ask me. Okay, Ziyad,
Yes, sir.
got it my points? Have you got
Yes,
this
sir.
question? This question have you got? Here initially two charges in air and at a distance d.
Yes, sir.
So simply I apply the Coulomb's law.
Yes,
When
sir.
two charges on air,
Yes, sir.
are in air, and after they are saying that if the magnitude of charges